Hello everyone, welcome once again. Now this is the first part of the sample distribution. So we have the question over here. The question says that suppose that the natural norm of a science test for 12 grade students on a particular year has a mean of 215 and then the standard deviation of 35. So let's write these parameters out. So we have solution here. We are given that the so this is a sample distribution. So therefore the question says that on a particular year it has a mean of 215. So with the 215 we have the mean here to be, which is the mean of the population mean, which will be 250, and then we are given standard deviation here to be 35 here. And then the a part of the question says that the random sample of 55 12 graders is selected. What is the probability that this group will average more than 230? So the question is asking for the probability. So the question is asking for the probability. So as you can see, a random sample of 55, which means that is the number of samples that we are given. So the number of samples is just the n, which is 55, and then it says that what is the probability. So we are to find the first part, the probability that this group will average more than that. So we have the mean will average more than that, so they are more than 230. So that is the probability that we are supposed to find, and this is what we call the sample mean, right? That is the sample mean. And then from our formula, since this is a sample distribution, this is a sample distribution question, and then we are given n is greater than 55, so which means that we are going to use this formula here. Why? Because we said that we use this formula when n is greater than 30, so we are going to use this formula here in solving that, right? So from here we have p here, and then we have z greater than, we have s bar minus mu here divided by the standard deviation over n here, that. So over here we have p here, z greater than, so our sample mean is just 230 here minus our population mean, which is 215 here, divided by this the standard deviation 35 here over the square root of the number of samples, which is 55. So from here we're just going to have this to be probability of z greater than, so computing the whole of this, we are just going to have this to be 3.18 here. So that will be 3.18. Then remember again, we said that if the probability for a particular distribution that we are given is greater than the value that we are looking for, always it is 1 minus the probability of that sample, right? So the probability of that sample. So in this case we can write this as the FAL of 3.18 here. Now remember this is 3. Now what we'll do here is to find this using the z table. So on the z table we are looking for the probability, so we look at 3.1 by 0.08 in this case. So 3.1 by 0.08. So as you can see on the screen, 3.1 by 0.08, if you look at it on the positive z table, we have this to be, so the whole of this now becomes 0.99926, and then when we compute this we have 0.00074, and that will be the probability of the sample distribution being greater than 230. But then to use the calculator, what we do is so in sample distribution, using the calculator for, as we did for the other part, is a bit different. So the difference is that when you go to the shift and then you go to start and then you choose your distribution, in this case we choose R in this case because basically it is greater. So R is 3. So when you choose 3, remember it is 3.18. So 3.18 here, and then we are just going to get that to be which is 0.00074, which is what we add over here. So you can also use the calculator in doing this also. Now let's look at the B part of the question. Now the B part of the question says that, so if you look at the B part of the question, it says that a random sample of 212 graded. So in this case we are given the number of sample to be 200, and then it went on to say that it's selected. So what is the probability that this group will average over 230 again? So we are given this to be 230, but then we are finding the probability that the sample is also greater than 230 over 230. So we still have this here. So basically we change this to z, then we have 230 here minus the mu. So mu is still 215 from the general question over the standard deviation, which is 35, but in this case the number of sample here in this question is just 200. So it changes, and then the probability that z is greater than, so when we compute the whole of this, we have 6.06. now let's look at this. We have 6.06 in this case, right? So we have 6.06 in this case, but then if you look at the z distribution table, the whole value starts from somewhere 0.0, so it has z here all the way to 3.9, as you can see on the screen, and then it has 0.01 all the way to 0.09, and then you realize that as you are moving downwards, the value will start increasing. So it will start increasing, it will start increasing, it will start increasing till, but then if you look at the last part, look at 3.9 by 0.09, you realize that we have something like 0.99996 something, right? Good. So which means that the z distribution table ends at 3.9, but then the value we are getting over here is 6.06, right? So how do we do that? So which means that if it ends as 3.9, and then if you look at the last value here being equal to 0.9999, which means that if we move to the next column, which is having like 4.0 by, let's say 0.01 or whatever, realize that approximately we are getting 1. So which means that any value more than 4, like you are going 4 and upwards, if you get any value more than 4 and upwards, then it should be equal to 1. So let's say for instance we got 16 here, then which means that it's basically going to be 1. When we get 5 here, it's going to be 1. 6 here is going to be 1. When we get 100 here, it's just going to be 1. So approximately it's going to be 1 in each and every case, as you can see from the table. So which means that our probability, remember, it is greater than, so we have the probability that z here 6.06 here, so we have greater than is 1 minus the whole of that. So when we do the file of 0.06, remember we said that approximately is just going to be equal to 1. So everything here is going to be 0. Now, how are we sure this is the right thing? Okay, so let's use the calculator and see what we are going to get. So from here we have the start, and then we go to 5, and then we use r because z is greater than the value, so we use r. So we go to r, and then we add 6.06 here, and then we realize that it will be equal to 0 basically. So which means that any value when it is more, it is on the table, and then it is more than what is given on the table, then approximately is equal to 1 in this case. So everything here goes to 0, because if you do the whole thing, it just gives you 0, straightforward. Good. Now let's look at the C part. The C part says that what is the probability that S bar is greater than 230 again? Still greater than 230 again. Why? Because the C part says that a random sample of 35. So we are given n here to be 35 in this case, 12 graders is selected, what is the probability that this group will average over 230 again? So still the same thing. So but just that we are looking at the sample size to be 35. So we have, remember, the sample mean is 230 minus the population mean, which is 215, divided by the standard deviation, which is 35, over the sample size, which is n is, in this case, is 35. So the probability that z is greater than, now when we compute the whole of that, we should get 2.54. now we have the probability that it is 2.54. so since it is greater, we have 1 minus the probability that so we can just put it in the file, and then 2.54 here, and then we look at it on the table. So we look at it by 2.5 by 0.04 in this case. So if it is 2.5 by 0.04, then which means that as you can see on the screen, we have this to be equal to just this part to be 0.99446, and then when we subtract this, then we are going to get 0.00554. so we can still use the calculator in doing this. Then again, we use the R. So we go to 5 distribution, and then we use R, and then remember it is 2.54 since it is still greater, so 2.54 in this case, and then we have this to be 0.00554. so as you can see over here, and then we have that. Okay, so that will be it for sample distribution. Thank you very much for joining me in this section. I will see you in the next section, still on sample distribution, but then we are solving it a different question, also in a different way. So I'll see you guys in the next section.